morning students. Today we learn about the differentiability. আগের ক্লাসে আমরা কন্টিনিউটি এবং ওটার অ্যালজেব্রিক প্রপার্টিজ এবং কিছু एग्जांपल দেখেছিলাম। টুডে আমরা ডিফারেন্সিবিলিটি কোন একটা ফাংশনের ডিফারেন্সিবিলিটি চেক করব এবং কিছু রিলেশন বিটুইন দ্য ডিফারেন্সিবিলিটি এন্ড দ্য কন্টিনিউটি এটা দেখব এন্ড সাম প্রবলেমস আমরা সলভ করব এবং চেক করব যে আইদার এগুলো কোন একটা নির্দিষ্ট পয়েন্টে কন্টিনিউয়াস or differentiable. So, a function f of x, suppose f of x is a function such that it maps from R to R. F is a function which maps from R to R, that is the domain and range both are the real numbers. Here, if I differentiate this x, this term can be written as limit of x plus h minus f of x by h. So this is the definition of the derivative which we have for the derivation of the function f with respect to x. Now, for checking the differentiability of this function, what we will do is that we will check the right-hand derivative and the left-hand derivative of the given function. So, how to find the right-hand derivative? The right-hand derivative is written as r f dash of x equal to limit h tends to 0 plus f of x plus h minus f of x by h, which means that h is tending towards 0 from the rightwards direction, and similarly the left-hand derivative is written as limit h tends to no minus f x plus h minus f of x by h. So, the necessary condition for a function to be differentiable is that the right-hand derivative of f of x should be equal to the left-hand derivative of f of x at x equal to a. For the condition of the function f of x to be differentiable at a point x is equal to a. Now, as we have achieved the necessary condition for the differentiability of any function f of x, now what we will derive is that the relation between the differentiability and the continuity. Remember the last class where we defined the continuity class. Now, we will see the relation between the differentiability and the continuity. If a function, যদি কোনো একটা function f of x at certain point x is equal to a, যদি এই ফাংশনটা x is equal to a পয়েন্টে, if this is differentiable, মানে if f of x at x equal to a is differentiable, then f of x must be continuous at x is equal to a. এটার মানে যদি f of x একটি ফাংশন x equal to a বিন্দুতে যদি এই ফাংশনটি ডিফারেন্সিয়েবল হয়, then obviously this function will be continuous. Now let's see for an example. let's take this one as example. Say we have f of x equal to 1 plus x square at x less than 1 and 2x at x greater or equal to 1. Now আমরা লাস্ট ডেটে কি দেখেছিলাম যে কোন একটা ফাংশনের আমরা কন্টিনিউটি বা ডিফারেন্সিবিলিটি কোন জায়গাতে চেক করি, যে জায়গাতে কোন একটা ফাংশনের ফেজ ট্রানজিশন হয়, লাইক ওটার ডেফিনেশন চেঞ্জ হয়। নাও ইন দিস ফাংশন x is equal to 1.8 এর ডেফিনেশন চেঞ্জ হচ্ছে। তাহলে so for checking the differentiability we first need to write the formula. Just তোমরা জাস্ট রিওয়াইন্ড ব্যাক করো, ফর্মুলাটা তোমরা পেয়ে যাবে। f dash x can be written as limit h tends to 0 f of x plus h minus f of x. Now we need to find out the right hand derivative of f of x, for which লেখা হয় limit h tends to 0 plus f of x plus h. Sorry. Yeah. So f of x plus h minus f of x by h. Now we are checking the right hand derivative at x is equal to 1, which means h tends to 0 plus f of 1 plus h minus f of 1 by h. এবার ফাংশনটার দিকে দেখো, যখন f of 1 মানে x is equal to 1 হয় তখন the value is 2x. Similarly, limit h tends to 0 plus h থেকে যাবে। Now 1 plus h is tending to 0 from the rightward direction, so h must be greater than 0. Hence 1 plus h must be greater than 1. H tending towards 0 plus, so h must be greater than 0, and hence 1 plus h must be greater than 1, which means if this term is greater than 1, then we will take this condition f of x is equal to 2x. So 2 into 1 plus h minus 2 into 2, which gives us limit h tends to 0 to h is equal to 2. So 2 is the value of right hand derivative of the function f of x at x is equal to 1. Similarly, this is the right hand derivative of f dash 1 is 2. Similarly, if we try to find out the left hand derivative of f of x at x is equal to 1, then we will write the limiting function as limit h tending to 0 from the leftward direction and f of 1 plus h minus f of 1 divided by h. Now simplifying it more, focus here, h is tending towards 0 from the leftward direction, so h must be less than 0, which means 1 plus h is less than 1. So the necessary condition for the function if x is less than 1 is 1 plus x square, which means limit f of 1 plus h means 1 plus h whole square minus This is 2x when x is equal to 1. So obviously this will be 2 into 1 divided by h equal to limit to 0 minus. Now if we expand this thing, what we will get is this thing. So we can cancel out this both h. So we have the value of this term as 2. Now we have right hand derivative of the function f of x at x is equal to 1 as 2, which is equal to the left hand derivative of f of x at x is equal to 1. So the function f of x is differentiable at x is equal to 1. Now, according to a relation between the differentiability and the continuity, if the function is differentiable at x is equal to 1, then this is also continuous at x is equal to 1. Now let's prove it that f of x is also continuous at x is equal to 1. Here, to prove continuity, we have three necessary conditions. One is f of a should exist or will have a finite value, and limit of x tending towards a at f of x exist, and obviously the left hand limit should be equal to the right hand limit, and everything should be equal to the f of a. So these are the three conditions for a function to be continuous at a certain point x is equal to a. Now, suppose from this function, what we have, we are trying to prove it continuous at the point x is equal to 1. So, if you find the value of f of 1, we will get a 2. Again, if we try to find out the left hand limit of this function f of x, then this will be written as limit x tending towards 1 minus f of x. So, limit x tends to 1 minus, or f of x means if x tending towards 1 from the left side, which means x is obviously less than 1. So, we can write it as 1 plus x square. Again, if we further if we go with this equation, then we'll find that the value of this limiting function is nothing plus 1 square, and that will be 2. Similarly, if we find the right hand limit x tending towards 1 plus f of x. Now notice, x is tending towards 1 from the right hand direction, which means x is obviously greater than 1. So we need to put this equation, but not this equation. if x is tending towards 1, and it is tending towards 1 from the right hand direction because here is a plus sign. So, if x is tending towards 1, suppose this is the number line, and x is tending towards 1 from this direction. So now obviously x is greater than 1. That's why we will put f of x equal to 2x but not 1 plus x square like in the previous equation. So here 2x will be put and we will get the result as 2. Similarly, you can see the left hand limit will be equal to the right hand limit. Hence, it is proved that if a function f of x is differentiable at x is equal to 1, then this function is obviously continuous at x is equal to 1 for this function. And if you are taking for the arbitrary function, then you can take any point x is equal to it. Now the second relation, আমরা প্রথম রিলেশনে দেখেছি that if any function f of x is differentiable, then it is must that it is continuous. But the reverse case is not true. The reverse case কি? Reverse case টা হলো যদি f of x, if f of x is continuous at a point x is equal to a, then f of x may or may not be differentiable. যদি কোন একটা ফাংশন x is equal to a পয়েন্টে যদি এই ফাংশনটা কন্টিনিউয়াস হয় তাহলে it is not necessary that this function will be differentiable. Unlike the case that if f of x is differentiable, f of x is also continuous. So রিভার্সটা কোনোদিন ট্রু হচ্ছে না এখানে। আমরা এটা সেম এক্সাম্পলের সাথে দেখে নেব যেটা f of x is equal to mod x. এই ফাংশনটি mod ফাংশনটি সবার কাছে পরিচিত। Now if we derive this mod function at x equal to 0, then mod x is equal to x when x is greater than 0. Mod x will be equal to minus x when x is less than 0. Obviously, and this is 0 when x is equal to 0. Now this is the definition of the function f of x. Now, to check the continuity, we need to follow these steps. Let us follow these steps. So f of 0, মানে যদি f of 0 বের করি, কারণ we are checking the continuity, check at x is equal to 0. We are checking the continuity at x is equal to 0. So f of 0 will be nothing but 0 directly from here, and limit x tends to 0. This is the right hand limit because x is approaching to 0 from the right hand side. So 0 plus. So f of x. Now if x is greater than 0, then f of x equal to mod x will be derived as x, which means limit x tends to 0 plus, and this is also equal to 0. Now we have to calculate the left hand limit, x tending towards 0 from the negative sides, and f of x, which means x is less than 0. So here this will be calculated as minus x. So limit minus x equal to 0 minus, which will be equal to 0. Hence, the first condition is f of a, that means f of 0 should exist finite. So it is finite, and limit of f of x should exist. For the condition of the limit of f of x to exist, obviously the right hand limit and the left hand limit should be equal, which is 0 for both of these RHL and LHL. Now these three should be equal to each other if this function f of x needs to be continuous. So f of 0 is equal to 0, and limit x tends to 0 plus f of x, this is also equal to 0, which is also the value of the left hand limit. Hence, this function mod x, f of x is equal to mod x, is continuous at x is equal to 0. Now let's check if this function is differentiable at x is equal to 0. Now, it is not necessary for this function f of x to be differentiable while it is continuous at this function due to this statement. Okay. Now let's see if this function follows this statement or not. For checking the differentiability of this function at x is equal to 0, let us first write the differentiability in the limiting form, that is limit h tends to 0 f of x plus h minus f of x by h. Student, তোমরা এই জিনিসটাকে thoroughly মুখস্থ করে নিও একদম, এটা সব জায়গাতে লাগে। যখন when you are trying to find the derivative of something with the help of limit, or when you are trying to solve the problems in differentiability, then you need this form. Or I think you must go through the derivation of this formula geometrically, because that's really fantastic. Now, left hand derivative of f of x at x is equal to 0, which gives limit h tends to 0 f of and x is equal to 0. So x is equal to 0, 0 plus h f of 0 by h. Now, just look at this, that f of 0 is equal to 0 because f in x equal to 0. So x equal to 0, which gives 0, equal to 0. So this term, look, here h tending towards 0 from negative side, because this is left hand limit. So previously I had committed mistake, because you guys will consider a minus sign here. Then h is, which means 0 plus h, that is h is tending towards 0 from the negative side, so h is obviously less than 0. Okay. Now, if h is less than 0, in this f of h, if h is less than 0, then we will have the function value of the function f of x as minus h, which gives us the value of minus 1. The value, left hand derivative of the function f of x at x is equal to 0. Now the right hand derivative of f of x at x is equal to 0. Similarly, we will go through this. F of 0 plus h minus f of 0 by h is equal to f of h by h is equal to, see, in this condition, h is approaching towards 0 from the right hand side, which means h is obviously greater than 0. So, if h is greater than 0, we have f of x as h, which gives the value of 1. So, here, the left hand derivative of f of x at x is equal to 0 is not is equal to the right hand derivative of f of x at x is equal to 0. Which means, we previously had this condition that left hand limit is equal to right hand limit. This condition is satisfied. Now, according to the statement, f of x is continuous at a point x is equal to a, which means at x is equal to 0, this mod function is continuous. This is proved by this equation. LHL is equal to RHL. But for differentiability, we need these two terms to be equalized. But this is not in this case, which satisfies this statement. It is that then f of x may or may not be differentiable. in case of this function, when f of x equal to 1 plus x square, and when x is less than 1, in this case of function, we have seen that if this function is differentiable, then it is continuous. But if this is continuous, it is not sufficient for the function, then it is differentiable. When f of x is equal to mod x. Now let us try to solve some problems. Now let us solve this problem. At first, let's see what this problem is stating. Is that f of x is given with certain function when x is less than 0, and c when x is equal to 0, and x plus bx square whole to the power half minus x to the power half divided by bx to the power 3 by 2 when x is greater than 0. Now we need to find a, b, c, the arbitrary values, the variables a, b, c, when f of x is continuous. এখানে দেখো, এখানে দেখার বিষয় হলো এই যে f of x is continuous. f of x সন্তত এটা দেওয়া আছে. Now let us solve it. For the continuity, we need to satisfy these three conditions. So these three conditions must be satisfied if continuity is prevailed in this equation. Now f of 0 is equal to c. Okay. Now the left hand limit. The left hand limit here, for the left hand limit x tends to 0 minus f of x. And x tends to 0 minus means x is less than 0, which means the equation will be this one. So when x is less than 0, then limit x tends to 0 minus, and sine of a plus 1 into x plus sine x by x. So we can write this equation as sine of a plus 1 by x plus this operation is seen in the algebra of the continuous function in the previous lecture. Now this is further simplified. So the left hand limit is a plus 2. Okay, now note it down. That is, the left hand limit is a plus 2. So the left hand limit is a plus 2. Now let us find out the right hand limit. It would be limit x tends to 0 plus, that means x is tending towards 0 from the right hand side. F of x means x tends to 0 plus, means x is greater than 0. So we will have this equation. This is x plus bx square to the power half minus x to the power half into b. We can write x to the power 3 by 2 as x into x to the power half. Now taking x to the power half as common factor, we will have x to the power half. So this x to the power half and this x to the power half gets cancelled. We have now here we multiply this thing. The numerator and denominator is multiplied by the same factor, root over 1 plus bx plus 1 to root over 1 plus bx plus 1, and that is equal to limit x tends to 0 plus and 1 plus bx minus 1. This is nothing but a plus b into a minus b is equal to a square minus b square. So bx root over of 1 plus bx plus 1. Right? Now these 1 and 1 will be cancelled. Then we will have only bx in the numerator, which will be cancelled by the bx in the denominator. So if we put the 0 in place of x here, what we will obviously get is nothing but 1 by 1 plus 0 plus 1, and that is equal to half. Now we need to find out the value of C, A, and obviously B. Now let us write it down. That is, the right hand limit is half. Here, for the necessary condition for the function to be continuous is obviously this f of 0 and left hand limit at x is equal to 0 and right hand limit at x is equal to 0, all of them should be equal. So if f of 0 is equal to right hand limit, then c is equal to half, right? And the right hand limit is equal to the left hand limit, which also implies a plus 2 is equal to half, which gives a is equal to half minus 2, that is equal to minus 3 by 2. Now, what about b? For this function b, we need to say that f of x is equal to this function x plus bx squared to the power half minus x to the power half divided by bx to the power 3 by 2, x greater than 0. When at this condition, now look, this function is defined for all value that belongs to R. Okay? No, not for all values. Here, this function is undefined when b will be equal to 0. So now, from this real number set of values, we need to subtract this set of 0. So this is the value of c, which means b belongs to any of these number from this set r minus 0. Now let us solve another. Now, তো আমি এক্সপেক্ট করব যে এই দুইটা প্রবলেম তোমরা বাড়িতে সলভ করবে, এবং যদি তোমাদের কোনো ডাউট থাকে তাহলে অবভিয়াসলি কমেন্ট সেকশনে আমাদেরকে জানাবে, এবং নিজের নাম এবং ক্লাস লিখে দেবে উইথ স্কুল, এবং উইল গিভ আওয়ার ইমেল আইডি ইন দ্য ডেসক্রিপশন সেকশন. So if you have any problem or you want to communicate with us in email ID, you can also do that. So like our video, subscribe, and also there are some other subjects. If you are interested to listen to them, so you can study them as well. They are really helpful. So also subscribe our channel and share our video with your friends. Thank you.